Here we will see the how to measure the effectiveness of our KNN. So how good this KNN is, how to measure this thing. Suppose let's take our these fixed data sets that we will got from our sample e-commerce website that I have seen you on the first lecture, how to collect the text data sets from, suppose I am just taking an example, Amazon's website. Okay, suppose let's take we have some text review data sets we have collected from some text review data set, that in the whole series of lectures just I am taking the same example. And also in the structure of a data set, one of this series of lectures we have seen how to represent the data sets. So our data sets will be look like this. Suppose let's take this is our data sets, and these things our features data, that is xi's, and for each row vector here we are represented by xi transpose. Okay, and a sample, and how to get this xi transpose, we will get this xi transpose from this text data. Suppose we have a review text I, and we will get this text, we will get this xi vector by simple transforming this text to some mathematical techniques, that is tf idf, word to vec, back of words, tf idf, some kind of techniques are here to convert a text to a vectors. We will see in the next series of lectures how to convert a text to a vectors. Suppose let's take, for now let's take here, this is our a text, it is a features vector for the text I, for a text I. Okay, and we have suppose let's take we have n number of data sets. Suppose 1 2 3 up to n, we have n number of data sets, and corresponding this one is I vector, and corresponding the age data also we have corresponding output, because we have sample taking this data is either positive or it is negative. For binary classifier, suppose let's take we have the corresponding output for this features vector, for the age vector, let's take it is our OII. This is the sample our data sets look like. Yeah. And also take our yi will be 0 or 1, yi will sample 0 or 1. 0 means in generally we have taken 0 for negative data sets, 0 for negative data sets, and 1 for the positive data sets. We have seen this thing, this structure in previous lectures also. Okay, now our the main problem is, now here our main problem is, for a given review, that is given review, that is if you just call review, or you just write down a problem. What is our main problem here? So our main problem is, for a given a new review that is totally different from this data set, from this data sets, for a new review, that is we call RQ, means query review. This is another language, query. We are just interested to find, to query about this review. What is its polarity? Simple, we are interested to find its polarity. Means what? Polarity means it is positive or it is negative. We are simple interested to find its query for this new review. Okay. So simple, what we are doing, for sample we have some techniques, and for this is this review sample text. Now for we text, we are sample converts this text to a vector, that is we call xq, by sample using back of word, or TF IDF or simple word to vec, we will see this kind of algorithms, or there are many, but these three are most popular one to convert the text to a vector in general. Okay, we are simple. So for a query review, we get a query vector, that is xq. Now we simple interest to find its a corresponding polarity, that is class level. We are interested to find, that is yq. It is actually positive or negative. Now the thing is that how to measure this problem, this problem will solve this knn algorithm. How much, just we are want to find a numerical quantity, how much effective this knn for a particular this data set. Okay, how to measure, the simple thing is how to measure this knn. Now we are simple find to a numerical quantity, means how much percentage. Okay, this algorithm, this knn is good for this particular, for a particular data set. Okay, let's see. So the thing is actually we have seen how actually the internals of knn works. So the knns works means we have find, we will see this thing. We will find the knn, means k nearest neighbor points. If we take k is equals to 3, then for s data sets we will find its 3 neighbor points, nearest neighbor points, plus we will find between them, we will find its majority vote. We will find this is majority vote, and depend, and among this, if our according to our majority vote of a class level, we have decided what will be the output of our query point. This is the simple trick of our knn algorithm. We'll see. Now the thing is that how to find this measurement. Okay, so let's see. So we have it. Suppose I think this thing will be clear if we redraw this data set again. Suppose what we'll get actually. Suppose if we just redraw this diagram. Suppose we have a data sets. Let's call our data sets is look like this. Suppose let's call this is our D data sets D. And we have n number of points, 1 2 3 4, let's take dot up to I and n. We have n number of points, and now, and also this thing is a features vector and corresponding output vector. This thing is our features vector, means xi's. This thing is features vector, and this thing is corresponding output vector, yi's. We have seen the simple structure of her. Now we are simple just dividing this thing in two parts. Suppose, and the first part is called the training data, and the second part of this data is called the test data. And how it divides? So in generally it is taken 60%, 40%. Typically we are using 60% for training, other 40% for test data, but there depends on situation to situation. So how we need to accurate depends on our problem actually, how to define. So this is the non-main thing. As a requirement we can easily divide. Now the thing is that, suppose let's write down the thing. Suppose we have for d n dimensions here, actually how much point we have? Actually we have n points, so we are calling our point n dn. Suppose let's take in training data we have n1 number of points, and for n2 d test data we have n2 number of points. So simple, we are dividing our training set dn into two parts. D train data, suppose D train data, and D test data, D train and D test data. Okay, and the how we divide it? So simple, D train The conditions of the divisions is that du train union of d test will be dn. If you just union it, we got that dn, and if you intersect it, actually there have no common points between the training set and test sets. So our d train intersect d test is actually 5. That is empty set. Okay, and this is the sample rule for divisions, the training sets and tests. Suppose let's take our d train, and the number of points d train is n1. We sample letting here. So the structure, and we have our data structure here is like that. We have pair of points xi and yi. Here xi is a vector points and corresponding y is its output or polarity or sample its class level. Similarly for test sets also we have pair of points, and our train data is lies from I is equals to 1 to from what n1, and test data is I is equals to 1 to n2. This is sample the our structure of the data sets, how we divide it. In generally it is divided in 60% of our whole data sets from training set and 40% from test set. This is typically we are using this. Okay, suppose now we are simple just apply this thing, how to measure these partition structures of these our data sets to measure its accuracy. Let's see. Suppose let's take first assume that for our easy of calculations, assume that k is equals to 3. We have sample assuming here 3nn means 3. We are interested to find the 3 neighbor points. Okay, so our d train, suppose like that, our d train point is like that. Suppose let's draw some pictures. Suppose our d training point is like that. This is some positive points here also some positive points. Okay, and here's some negative point. Here's some negative point. Okay, this is sample. Suppose let's take this is sample our training data set. This is sample our training data set. Okay, this is sample our training data set. Now the here what actually we have to find, we have to find the is accuracy. So just this data set, this thing is coming from here, this thing is coming from here, this structure is coming from. Now we are interested to measure its measure. How to measure? Suppose we are to measure this, how we are require a new point. So for h, now how to get a new point? So here we have taken h points from our test data sets as a query point or new text point, and we are finding its output by sample using the training data sets and knn. So let's see how it works. So now we are picking the h point. Now I'm just using the different color. So we are picking a h point xi from d test data set. This is sample how much point, their point is look like this one, this pair of points I is equals to 1 to n2. This is the simple, this is the our in text 2 we have n2 number of points, so our test data also look like this. So simple for h point xi that we pick from our text data set, we are calling this thing our query point. Okay, so first query point, let's take that query point is, suppose let's take first query point is taken from this text test data here from x query point, or for each point in d test. Just take first point, I have a query point, just see this thing. So now here if you just take a one point here, suppose let's take this point, this x1 point is now lying on here, this point. So what will be the three ANNs will be, I think this thing, the 3 ANN will be this thing, 3 ANN, 3 neighbor points. So what will be the majority vote? Blue color means positive classes. So what will be the, so according to this thing, what will be the our points output, query points output? So our KNN from the training, according to training data sets and KNN algorithms, we got our YQ will be positive or simple blue. Okay, so what we are taking, just to see this thing. So we are, how we find it? So simple, we are finding by some, first we are just taking a point, query point, we are taking a point from t test, each point in d test, and in second step what will do? In second step used by simple, use what? Use dtrain and KNN to predict our YQ. This is the sample. Use simple. First we are taking each point from d test and we are finding corresponding output with the help of training data sets and KNN to predict the output. Now to using this output, what will just see as algorithm, let's just relate as algorithm. Okay, I think they need to be better. So what we are doing for each point, we are doing for each point in d test, we are just running a loop first for each point in d test. So let's take first, we pick up a point and call it xq. Suppose we are taking point, we are just pick this point from our test data set and we are store it in xq. And sample here in second step, what are we doing? In first step doing that. In second step we are doing use sample training data set and KNN algorithm. KNN means k nearest point, and some from our training data sets we have determine our YQ according to the majority of this KNN. We are predict if, and then what will doing? If, and for x point, for we have just, if you see this, we are taking the h point from here up to here, n2 number of points. Here our point for 1 2 3 dot here up to n1 number. Just we are picking h point first, 1 point, then 2 point. First we are picking h point, and corresponding they are also have some OIIs. Now for h point we are calling xq, and xq, suppose we are calling x here, x point. Suppose you are calling the point, we are just taking the data set like that. We have x, actual point is x point, and corresponding actual output is y point. Means here y point is lie on actual here, ypt actual lie on here. Okay, here even, and just YQ is just simple, we have get it from our using training data sets and KNN algorithm by simple majority technique of find majority of KNN, this KNN. So if this YQ is equals to, compare this, is equals to actual output, means actual y point, then if yes, then we have simple count it. Count, I have increased, count is equals to count plus 1. Okay, and initially we are assume count is equals to 0. If it is correct, then we are simple increase the count value. In then it is simple is the increase the count value. And simple, and here our we have end our if loop, and simple after that we have end our forward loop. Okay, this is the simple algorithms. So at the for each point we have run this forward loop, and for each point also we have compared this output that is coming from detrained datasets and KNN algorithms. If it is actually correct, then we are increasing the value of count, otherwise we have done nothing. So after end of this loop, what will get? So after end of this we get a number of points. After end of this loop we get number of points, and for which dtrain plus KNN gave a correct class. Gave a correct class means correct output. Okay, actually this thing from here count will be increased when our actual result is true to our original class level, then only count is increased. So number of points which dtrain and an algorithm gave a correct class level. From this count is actually doing this job. Now how to find the accuracy of this? So now the accuracy will be now the accuracy will be simply our this count value by n2. n2 means what? Number of data points in the test data set. Number of points in the test data set. This will be the sample our accuracy. Means our count, actually we are running this forward loop, all the points in d test. So the maximum value of the count will be n2 if all the correct class level is correctly classified. Then our count value will be n2, otherwise it is less than l2. So this n2 just so this accuracy value will always be, this accuracy value will always be less than is equals to this accuracy value will be greater than is equals to 1 and less than is equals to greater than is equals to 0 and less than is equals to 1. Okay, I think I'm also write down this thing. This n2 means number of points in the test, and this count means this count. This count means this count. I think clear. This accuracy value will be this one. So suppose let's take let our accuracy value, suppose let's take our accuracy is 0.91. We got it. So this means what? This means we got 91% of times accurate our actual. According to our D-trains and KNN algorithms, our D-test that is totally different from our D-train. Our D-test we have find the accurate value for our D-test to 91% of time. 91% time we got the accuracy value for D-test data. Or D-test data. That means we got 91% of times the correct result, right? Correct class level for D-test data. This means that 91% of times we got correct class level for the D-test data. This means that simple. We are putting this query point, and by applying this thing we got YQ. How we will apply this thing? By simple using our D-train datasets plus our KNN algorithm and this query point is coming from our D-test dataset. Okay, if we got this, if actual output is equal to our actual class levels of our test data set, then we can count one, otherwise you have to know. This is the simple thing. Okay, now the conclusion is that now the conclusion is that the conclusions is that so knn on a knn, if you just using this simple accuracy value, we can conclude that our knn algorithm on this text classify the text data that we are interested, that we have collected from our sample text review data, or this text review data, text review data by sample using training data set, it gives me an accuracy of 91% on test data. So it could be vary on another text data, but on our D test data, we got it 91%. Okay. I think actually this is one way to find the accuracy. Sorry, this will be accurate. This is one way to find the accuracy. So there have many kinds of accuracy, how to measure the accuracy. This is the simple concept to find the accuracy. Okay, so what we're doing in dtrain, we have sample doing two tasks. First, on dtrain we are dividing the dtrain data sets and sample by using knn algorithms on these dtrain data sets, and we have predicted the class level of the dtest data set. Okay, xi, we have predicted this yq value. Here it is actually quite xq value, yq value, and this yq value is comparing with our this y point, actually our point like this yp, here actual output, we are comparing this yp. Okay, and it's according to that we have finds its accuracy. Okay, and this is the one kind of accuracy. This is one kind of, in the next chapter we will see there are various many kind of accuracy. We will see these things, but this is the simplest technique to find the accuracy. I think how to measure the accuracy of a knn is clear, all of you. Okay.